So in today's video we are going to discuss about the procedure. As you guys all know, in the previous video we have discussed about the monoclonal antibody. Now we are going to discuss about the procedure, that how the monoclonal antibody basically made. Okay, first of all, uh, the antigen for which we have to make the monoclonal antibody, we are also saying this as a MAB. Monoclonal antibody also used for the rheumatoid arthritis and the autoimmune disorder. Okay, we are going to discuss that very soon in the next videos. So we are having 8 steps. First one is to choose the antigen or a vector, you can say that. Second is we will be putting injection. Okay, third that the fusion will occur. Fourth is the hybridoma formation. We are going to discuss one by one all the steps. Okay, fifth one is mitotically division, and sixth one is the testing or detect or culture. Seventh one is to extract and to insert in any body, utilize in body. Okay, first of all, let me give you the introduction about the monoclonal antibodies. An antigen which is having the one binding site, we are calling that as a monoclonal antibody. Okay, which means having the one epitope, and the plasma cell will make the one antibody for that epitope. That is called the monoclonal antibody. If there are many epitope and many plasma cells are using to make the antibody, so we are calling it a multiple monoclonal, multiple or polyclonal antibody. Sorry, yeah. So first of all, it is very costly technique. Okay, so if we talk about the monoclonal antibody, why we are doing this technique? Why? Because if we talk about our body, so our body take with like very much long time to make this monoclonal antibody. Okay, for example, a patient is having a snake has bite a patient. Okay, and the poisonous substance is spreading in his or her body. So if we talk about our body, so that will consume time to make the monoclonal antibody. So what we are doing, we are making the monoclonal antibody in another, or you can say the non-human organism. Okay, and after that we will be getting through that non-human um, antibodies, and we'll be extracting them, and we will utilize into a the body to, like, on which the snake has bite. Okay, so first of all, if we talk about the first step, we are having the to choose a antigen. Like which antigen? For example, we are choosing a rat, mice, rat, for example. Okay, so for example, the pathogen we have inject into um body, into his body. Okay, so what will be occur after injecting the pathogen from the like the pathogen? So what will occur? The immune system of the mice will be get active after the inserting the pathogen, and their plasma cell will make what? Antibodies, start to make antibodies. Okay, but it will got dead. Why? Because our step 2 is injection. So pathogen inserted into the rat body, after 6 to 10 days it will get dead. Okay, so after that, when you can say that the body will start antibody, to make the antibody. So what we will do, this third step, if we talk about, we are having on the second step. Okay, so from their spleen, the rat spleen, we will take the plasma cells which will be making the you can say that antibodies. Okay, because plasma cell is having the lifespan very less, so we are taking the spleen, from the spleen, plasma cells, or you can say that as the splenocytes. Both are same. Okay, plasma cells are the type of the WBC which are going to make the antibody against the antigen. Okay, and we also extract the myeloid cells from the myeloid cell from where? From bone marrow. Why we are taking the myeloid cells? Because myeloid cells is having to divide like very rapidly. Okay, what are myeloid cells? These are the tumor cells, like the cancerous cell. Okay, so they are having the uncontrollable dividing ability. Okay, so what we have did, plasma cell and myeloid cells. We have extracted the plasma cells and myeloid cell. Okay, now we are talking to about the step 3, which is fusion. What will occur? You can see that step 3. So plasma cell and myeloid cell, for the 3 step for the fusion, the chemical we will use, which will be the PEG, which is the polyethyl glycerol. Okay, just from this chemical the genetic change will occur because of the fusion, and just because of their both fusion, a new cell will be developed, that will be the hybridoma. What is hybridoma is basically the genetically modified cell. Okay, hybridoma formation, fourth step 4. So the genetically modified cell, which is having ability to make the antibody and to divide rapidly. Okay, we can also destroy these by the radiation. So our fifth step is what? The mitotically division. So they are having the ability to divide. Okay, so it will be divided into the daughter cells. Okay, because it is having the ability to divide, so it will be divided. Okay, after the mitotically divides, we will be do the testing. We are having a testing medium, which is HAT. What is HAT? HAT is the hypocythine aminopyrin thymidine. Okay, this is the testing medium to test. Okay, that some cells don't grow, so they'll be getting separate out, and some cells which are growing, they'll be continue to check the test, like the they have divided or not. Okay, so after this we are having the seventh step to extract. So we will be extracting those, you can say that the cells. Okay, and or they are making the antibody, so we'll be extracting that antibody extract. The antibody will be extracted, and this eighth step is to utilize into the body. So we'll be extract that antibody, and we'll be through the vaccine we will utilize into a human body. This technique is very costly, and this basically you can consider work in the genetic engineering. Okay, so if we talk about the example of the any treatments, which is the cancerous cells we are having, this is basically we can do the treatment of this from the monoclonal antibody. Okay, so we are having the we will be diagnosed, and we are having the treatment. So this was about the procedure to make the monoclonal antibody from the antigen. Mostly we are taking the example of the rat. Okay, antigen. So here we are having the monoclonal antibody.